This video is for section 2.2, right triangle trigonometry. In this section, we will introduce with you 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. We will use a right triangle. A right triangle is a triangle that has an angle of 90 degrees. We will label the sides of a triangle using capital letters, A, B, C, for example, and we will use small letters to label the sides. The little a is the side opposite to angle A, little b is the side opposite to angle B, little c is the side opposite to angle C. We will denote the angle A, for example, as angle theta, and we will write formulas for trig functions for this angle. We will use the following names for the sides of the triangle. The side that lies across of angle theta in the triangle, we're going to call opposite sides. So side opposite to the angle. A side that is next to the angle, that creates the angle, is going to be called adjacent side. And the side that is opposite to the angle of 90 degrees is called hypotenuse. We'll use these names to give definitions of the functions. Sine will be defined as the opposite side over hypotenuse, or A over C. Cosine is adjacent side over hypotenuse, or B over C. Tangent is opposite over adjacent, or A over B. And then the remaining 3 functions, cosecant, secant, and cotangent, are defined as the reciprocal of these values. So cosecant will be hypotenuse over opposite, C over A. Secant is hypotenuse over adjacent, or C over B. And cotangent will be adjacent over opposite, or B over A. Let's apply these formulas at the following examples. We need to evaluate the 6 trig functions for angle A for the following triangle. In this triangle, angle A is here on top. So let's first identify where we have opposite, adjacent, and hypotenuse here. Hypotenuse is always across the angle of 90 degrees. So this side is hypotenuse. If we put here C for angle C, so we can say that hypotenuse is little c is right here. Across from angle A is opposite side, so this is opposite side. And next to angle A is adjacent side, so this is adjacent. In order to apply the formulas, we need values for all those 3 sides. We have only value for adjacent and opposite side. We need value for hypotenuse. We can find it using our regular formula: a squared plus b squared equals c squared, Pythagorean identity. So let's plug in. A is 11, A is opposite to angle A, 11 squared. B is 6 squared, so this is B, equals c squared. We can put this in calculator. 11 squared plus 6 squared is 157. And we can take square root. So the square root of 157 equals to c. So c, hypotenuse, is square root of 157. Now when we define sine, we're going to say sine is opposite over hypotenuse. So it will be 11 over square root of 157. We don't like to leave radicals in the denominator, so we're going to rationalize this fraction by multiplying top and bottom by square root of 157. So the answer will be 11 square root of 157 on top over 157 on the bottom. Cosine is adjacent over hypotenuse. Adjacent is 6 over 100 square root of 157. Adjacent over hypotenuse. Again, we're going to multiply top and bottom by the square root of 157 to get our final answer. We are rationalizing denominator. 6 square root of 157 over 157. Tangent is opposite over adjacent. Opposite is 11, adjacent is 6. In this case, no radicals at the bottom, no need to do anything. Cosecant, hypotenuse over opposite. Square root of 157 over 11. This is final answer, don't need to simplify. secant, hypotenuse over adjacent, square root of 157 over 6. And finally, cotangent is adjacent over opposite, so it will be 6 over 11.